All right, today we're going to be looking at lesson 1.4, which is the distributive property. And before this lesson, we were exploring order of operations. And now we're actually going to take it. Look what happens when we do have something like order of operations, but there's a variable involved. What can we do to simplify that? Okay, so the first thing we're going to do here is we're going to define the distributive property. And the distributive property, let me zoom in here real quick. The distributive property is defined as A times the quantity of something like B plus C. Now it doesn't matter if I have addition or subtraction there. So if I want to have A times the quantity of B minus C, that would be fine as well. And what the distributive property says is that I need to take A and I'm going to multiply it by both parts on the inside. So when I do that, I'm going to get AB plus, just keep your sign the same, AC. Same thing with subtraction. So you'll end up with AB, and then you're going to have a minus AC. And that is kind of what the distributive property entails. So we're going to look here at our first example. Oh, sorry here. It says simplify using the distributive property. Okay? In our first example here, we're going to look at 5 times the quantity of G minus 9. All right? So we're going to multiply both parts. Multiply by what's on the outside by both parts on the inside. So I'm going to end up with 5G minus 45. Now, I can't put these together because this has a variable of a G in it and this has no variable. So they can't go together. So this is going to be my final answer. Okay? All right, so let's take a look at the next example here. So on the next example, example number 2, you're still going to multiply the 3, so what's on the outside, by everything that's on the inside. It's got to go to all 3 parts. So when I do that, 3 times 2 is 6. Just keep the x squared there. Plus 3 times 4 is 12x. And then 3 times negative 1 is negative 3. Now again, I cannot put the x squared and the x together because those variables are not the same. And since they're not the same, this is going to be my final answer. All right, so example 3. Now, don't let it confuse you when they decide to stick a negative or anything on the back side here. You're still just going to go ahead and drop it on inside the parentheses. So I'm going to take the 3 to the 2 and the 3 to the 5. So I'm going to have negative 6 minus 15q. Okay? All right. The next part here is to define a few vocabulary words. The first vocabulary is actually reviewed from lesson 1.1. And it's called a term. Remember, there were 3 parts to a term. The first one was simply, it can be a number. The second one can be a variable. And the third one can be a number times a variable, or the product of a number and variable. All right, the next term we're going to look at is called like terms. All right, and the definition for like terms is a term that contains the same variable or variables. Okay, multiple, you can have multiple letters there, with the same exponent. So an example here of what we're kind of talking about would be like if I have something 2x plus 4x, I can put those together because they both have x's, so I could call that 6x. If you have something like 2x plus 4y, that is simplified form. There's nothing I can do to this because I have different letters. So back over here, this would have been your final answer. And then the 2x plus 4y, there's nothing I can do with that. Okay. All right, so now let's go down here to the next problem. So if I'm looking at this, these are like terms because they're the same. So I'm going to take 15x plus 18x, and I'm going to end up with 33x. So I'm just adding those front numbers, the 15 and the 18, to get this final answer. And that's it. All right, example number 5. All right, now on this, These are not all like terms because notice this guy right here does not have the squared like these two. So this front guy right here has an exponent of a 1, so those are not the same. So I can put these two guys together because they both have a squared after it. So my final answer here could be 10n plus 12n squared. Now it doesn't matter if you choose to put the 12n squared out front plus 10n, it's the same thing. Either way will be fine. All right, example number 6. So now we're going to now apply the distributive property to this, and we're going to distribute the 4 first. We have to do the parentheses first, and then we'll combine like terms. So 4 times 7 is 28a, plus 4 times 4 is 16, minus 6a squared, minus 2a. Okay, and so now we're going to combine like terms. So if I'm looking at this, I've got an a and an a here. And then the 16 and the negative 6a squared doesn't have anything else you can go with. So when I'm writing this down, I'm going to have 16, I'm going to have a minus 6a squared. And now I need to be careful when I do this 28a and 2a, keep the sign right here. So 28a minus 2a is 26a. Again, order's not important here, just as long as you have all the parts. Okay. All right, our next vocabulary word is equivalent expressions. And the definition for equivalent expressions is expressions. Try it again. There we go. Expressions that denote or you could say represent the same value for all values of the variable or variables. Okay. All right, and the next one is simplest form, and this is just when an expression is replaced by an equivalent expression having no like terms or parentheses. Okay, so we've got to get rid of those parentheses when we're doing this. All right, so let's take a look here. Oh, okay, we're going to go ahead and go to the next page. And the last word we're going to define today would be coefficient. All right, so coefficient is the numerical factor of a term. And so, an example here is if I have like 3m, the 3 is my coefficient. That's what that is saying. So it's just the number out in front of a variable pretty much. All right, so let's take a look at this. Okay, it says 5 times the difference. Okay, so think about what our vocabulary words were from lesson 1:1. So 5 times the difference. We know that different means subtraction. Okay, so we know we're going to subtract of q squared and r plus 8 times the sum of 3q and 2r. Okay, and sum means addition. Okay, all right, so now the other thing that we have not talked about in class yet was difference. While it means subtraction, it also tells you that you can have parentheses. Same thing with the word sum. It means addition, but also that it's probably going to include a set of parentheses. So step A here says write an algebraic expression, so no equal sign, for the verbal expression. So when I write this, I'm going to have 5 times, I'm going to put parentheses here, q squared and r. So those are the two things I'm subtracting. Okay, plus, so there's my plus sign, 8 times, and then the word sum is telling us parentheses, 3q, and 2r. Okay, so that's my original expression. Now simplifying it, and this is where I'm going to put it in simplest form. I'm going to clean it all up and put things together the same at the end. All right, so I'm going to start by distributing both parts on the 5 here, and then I'm going to distribute the 8 to both parts. So I have 5q squared minus 5r plus 24q plus 16r. And so what I'm looking for are like terms. Well, in this case, the r's are my only like terms. I can't put that q squared and q together because those have different exponents, okay? So I'm going to have 5q squared plus 24q, and then I'm going to combine negative 5 and 16 and get 11r, okay? So now when I'm looking at these, all of these guys right here are the equivalent expressions. So that vocabulary word we just talked about, equivalent expressions, all these guys are saying the exact same thing, okay? The 5, the 24, the 11, those are all coefficients, all right? So the 5, the 24, 11 are coefficients. And then this guy right here is your simplest form, okay? Simplest form, all right? And that ends today's lesson.